So we'll be graphing quadrilaterals on the coordinate plane. There's just a lot of stuff that we're putting together here. When it's on the coordinate plane, we're going to be using the distance formula. We're going to be using not only just area and perimeter, we're simplifying radicals because we want to have the exact answers on some of these. And so I'm pretty sure that you'll probably see something like this on the part test. So here is the first one where you have all the coordinate points. We got to figure out what geometric shape it is. So let's go ahead and let's plot these points. So we have A at 1, -2. So 1, -2 is right here. So A is right here. 3, 0 is right here. So this is B. -1, 4 is right here. And -3, 2 is right here. So it appears to be a rectangle, but we have to make sure that that's what it is. And so we look at making sure that each of the corners are 90 degrees, or in a rectangle it just needs to be, one of them needs to be 90 degrees. So let's look at the slope of DA. So the slope of DA, if we go down 1, right 1, down 1, right 1, we continue to do that, the slope is -1. The slope of AB should be perpendicular to that, and so remember, flip it, change it. So with AB, you're going up 1, right 1, up 1, right 1. So yes, the slope indicates that they are perpendicular. So we do have a 90-degree angle. So the next thing that we need to check is to make sure that the opposite sides are parallel. And let's see, so if we have DA, we already said that the slope of DA is -1. Is the slope of CB -1 as well? So we're going down 1, right 1, down 1, right 1. So yes, CB is also -1. So the slope is -1. So we say that those opposite sides are parallel. Let's see, CD. So the slope of CD is +1. So let me erase this so that we can see it better. So we're going up 1, right 1, up 1, right 1. So CD is +1, and is the slope of AB, is it +1 also? If you look at it, you're going up 1, right 1, up 1, right 1. Okay, so yes, the opposite sides are parallel. So yes, there's enough information here to show that this is a rectangle. All right, as we continue on, we will be able to prove also that that CB and DA are the same length. The opposite sides have the same length. So let's go ahead and let's look at these. You've got to use the distance formula, and I'm going to show you 2 different ways. I'll show it to you using the coordinate points, and I'll show it to you graphically. To be quite honest, graphically is my preference. One of the things that's kind of nice is that even though you know the distance formula, it's good to understand that the Pythagorean theorem, the distance formula is derived from the Pythagorean theorem. So if we look at the length of AB, okay, and whenever you use the distance formula, you do want to indicate which side. You cannot just put D equals. We're trying to find the length of AB, and so you've got to write that down. I've had students that would figure out the distance of a line, and when I ask which line it is, they couldn't tell me. So remember, the distance formula is the difference of the x's, so it's 3 minus 1 squared plus the distance of the y's, which is negative 2 minus 0 squared. So let's keep going with this. 3 minus 1 is 2, so it's 2 squared plus negative 2 squared, which ends up being the square root of 4 plus 4, which equals the square root of 8. And so we've got to simplify this. Simplify the square root of 8. Simplify the radical. Oh, I think we'll do just the cake. So we have the prime number of 2 that goes into 8 4 times. 4 is a composite, so we put the cake around that. 2 goes into 4 2 times. And so we would have circle 2. The 2 of them goes outside, and the other 2 is left in jail. I'm wanting you to be able to see how the reason why it works this way. I'm hoping that I can explain it. The square root of 8 is the same thing as the square root of 2 times 2. And if you have these 2 times 2 is 4, and which is a perfect square. So when you circle 2 and take out 1 right here, that's the reason why, because the square root of 4 equals 2. Also, see if you can see it. This is also equivalent right here. And so we know that the square root of 4 times the square root of 2 equals the square root of 8. Well, the square root of 4 is 2. So I'm hoping that explains things a little bit better as to how we simplify this radical. So we know that the length of AB is 2 square root of 2. If you were to put into the calculator square root of 8 and then push enter and then 2 times square root of 2, you would have the same number. It's an ugly number, it's an irrational number, but nonetheless, they are equivalent. Now let's look at it on the graph. Let's look at AB. And so what I want to do is I want to use the grid where AB is to where the hypotenuse of a right triangle is AB. So if I draw a line here, it's hard to do this to where it doesn't. And this way, I have a right triangle, and AB is the hypotenuse. And if I look at the length, this length 1, 2, this is length is 2. This length here is also 2. And then I use the Pythagorean theorem. So I'm going to indicate AB again, because that's the length that we're looking at. And it's 2 squared, A squared plus B squared. See how it looks familiar with what we were doing right here? They kind of look the same. See this right here? So the distance formula does come from the Pythagorean theorem. And so if you can make your right triangle on the graph, you'll be good. So let's look at the opposite side here. If I make DC also a right triangle, this is 2. So that shows that the opposite sides are the same length. So let's look at BC. So I'll use the coordinate points again. I'll do it the same way. BC. So again, we have to indicate which side that we're talking about. If we do not do that, then it's going to be hard for you to be able to refer to your work on this. Okay, so BC. So BC is the square root of the difference of x's. So it's 3 minus -1, which is 3 plus 1 squared. And the difference of y's is 4 minus 0 squared. So 16 plus 16 square root is the square root of 32. So let's go ahead and let's simplify this radical using the cake. Sixteen still composite. 2 goes into 16. 8 is composite. 2 goes into 8. 4 is composite. But 2 is prime, so don't put the cake around the 2. So we circle 2, and we leave those outside the radical. If you need to, just draw your radical just to figure out what goes in and stays out, and we're multiplying those. And then this 2 right here is left in jail, so we have 4 square root 2. All right, so now let's look at it graphically. So whenever you make your right triangle, when you start at the point, you go along the line of the grid. And you're either going to go up or down, left or right, and just figure out where they're going to meet. So C, I'm moving right. B, I'm moving up. And so I made my right triangle. So if you look at it, so the sides are 4 and 4 right here. Another way to also look at this is that we've got special triangles. If you've got a special right triangle, this is a 45, 45, 90. We can go ahead and use the Pythagorean theorem, but just know that on a 45, 45, 90, the hypotenuse is 4 square root of 2, and that would have worked the same way with AB, because you have this, and so it's 2 square root of 2 as well. Okay, so let's see, is AD the same length? Let's look at it. So I'm moving down, from D, and I'm moving left. See, I'm only following the grid. So this length is 4, this length is 4. So the opposite sides are congruent. So we definitely know that this is a rectangle. All right, so it's cleaned up a little bit because I need room still. So now we've got all the information. We know that this is a rectangle. Opposite sides are congruent, and we have perpendicular lines forming 90-degree angles. So now let's go ahead and find out area. So we know that the area is base times height. And so the base, we're going to say that the base is whatever AD is, and AD is 4 square root 2. The height is whatever AB is, which is 2 square root of 2. So let's go ahead and let's put it into the area formula. I'm going to substitute 4 square root of 2 times 2 square root of 2. Now, one of the things I always like seeing is if I've got square root of 2 that are the same, that are multiplied twice right there, that comes in really handy. You always like seeing that. And the reason why is because square root of 2 times square root of 2 always equals 2. Now I always hear, okay, square root of 2 times square root of 2, square root of 4. Well, what's square root of 4? It's 2. But I'm wanting you to see that anytime you have square roots that are multiplied, that it equals that number without the square root. I will even move this around to where I have the numbers multiplied that are outside the square root. See right there? That's what we want. So now we have 4 times 2, which is 8, and square root of 2 times square root of 2 is 2, and 8 times 2 is 16. So the area is 16. Now let's find the perimeter. On the perimeter, we have to add up the sides. So let's get that ready. So our perimeter is going to be whatever AB. I'm going to go ahead and have the opposite sides plus DC plus BC plus AD. And so if I do my substitution for those, see, we said that AB is 2 square root of 2. DC is also 2 square root of 2. BC is 4 square root of 2. And AD is 4 square root of 2. And so since we have square root of 2 on all of these, then we can add those together just like what we do with variables. Like, this is just a side note. If I've got 2x plus 2x plus 4x plus 4x, you know how to add those. That's combining like terms. Well, this is kind of the same way with the square root of 2. All of these numbers have square root of 2's. So if I've got square root of 2 plus square root of 2 right here, then that's 4 square root of 2. And then I'm just bringing the rest down. Then square root of 4 square root of 2 plus 4 square root of 2 is 8 square root of 2. And then we add these together, so how many square root of 2's do we have? We have 12. Okay. So my perimeter is 12 square root 2. So let's try this one. Let's go ahead and plot the points on this one. Negative 4, 4. It's here. Negative 1, 6. It's here. And negative 5, negative 1. Is here. And 4, 5. Is here. And if we were to go ahead and connect these, it looks like it's a trapezoid. Well, the property of the trapezoid is that you have to have one set of parallel lines. So let's check this out. If we were to look at the slope of AB here, the slope of AB, we're going up 2 and right 3. So it's 2/3. This is for AB. We're looking for the slope. And so now let's look at CD. Is it going up to right 3? Yes, it is. So CD, which is the slope, is also 2/3. So the opposite sides are parallel, so we definitely know that this is a trapezoid. So now, if we are going to look at area and perimeter, well, with the trapezoid, particularly the area, we have to figure out what the height is. And so the height has to be perpendicular to one of the bases. Okay, so just remember that on a trapezoid, this is base 1 and this is base 2 right here. Well, since we already know that AB is, the slope of that is 2/3, for it to be perpendicular, you have to flip it, change it. So it's negative 3/2. So that means that you're going to go down 3, right 2, or you're going to go up 3, left 2. Well, if I'm going to start at A right here, I'm going to go ahead and use the down and right. So I'm going to go from this point going down 1, 2, 3, and then right 2, 1, 2. And so now my point's going to be right there. So that's going to be my height, which is perpendicular. All right, so now I've got to find the length of my base 1, my base 2, and my height for my area. So here's my base 1 right here. And so I'm wanting to use the distance formula, but you know what? I'm going to start using the graph. I showed you how to do it with the 2 coordinate points, but this is so much faster. So this length is 2, this length is 3. And so This is my base 1, which I'm finding the length of AB, and I'm using the Pythagorean theorem. So it's 2 squared plus 3 squared, and that's the square root. 4 plus 9. You'll be happy to know that we don't need to simplify that radical. It's already in simplest form. Let's look at base 2. So I'm going to draw my right triangle. Remember, you just go along the lines. Okay? So go this way and this way. So this length is 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So my base 2 is whatever the length of DC is, which is the square root of 9 squared plus 6 squared which is 81 plus 36. And 81 plus 36 is the square root of 117. Now, we may want to assume that this is in simplest form, but actually it's not. If you look at, remember the tricks of figuring out numbers, what they go into, that if you add the digits of the numbers, that's what 3 can go into. If you go 7 plus 1 plus 1, that's 9. So 3 does go into 9. So I'm going to simplify the square root of 117 using the cake. So 3 goes in 117, 39 times. 3 goes into 39, 13 times. And circle 2. If you need to, draw your square root so that you could see what goes on the outside and what stays on the inside. So now we've got the length of what DC is. Now let's look at height. So I've had my H, and so I'm going to draw my line here and here. So this length is 2, this length is 3. So it looks like it's the same length as whatever AB is, because AB has the sine lengths of 2 and 3 here as well. So we can go ahead and go through the process, but we know that H is also going to be square root of 13. And so our formula is H divided by 2 times the quantity of base 1 plus base 2. So let's go ahead and let's figure the area. I'm just going to write it here so that you can see how we're doing our substitution. And if you understand fractions well, you put the base 1, the quantity of base 1 plus base 2 next to the H. Okay, if you put it right in the middle, then we're not fully understanding how we add, subtract, multiply, and divide fractions. So we have square root of 13 over 2 times base 1 plus base 2. So I'm going to take care of the parentheses. So we have 1 square root of 13 plus 3 square root of 13, which is 4 square root of 13. Okay, so if we were to go ahead and multiply this, see the peanut right here? 4 divided by 2 is 2. So I've got 2 times square root of 13 times square root of 13. And remember what I told you about the square roots that are exactly the same? It's what we want to have right here. Square root of 13 times square root of 13 is only 13. So 2 times 13. So my area of this trapezoid is 26. Now let's go to perimeter. So we already know that the length of AB is square root of 13. We already did that. And we also know this length is 3 square root 13, but we do not know the lengths of the legs of this trapezoid. So if we go ahead and draw our right triangle, this length is 1, this length is 1, 2, 3, 4, 5. So this length is 5. So let's go ahead and use the Pythagorean theorem, and I'm trying to figure out the length of AD. So it's 5 squared plus 1 squared, which is 25 plus 1 square root, which equals the square root of 26. We cannot simplify that any further. Now, if we were to look at the length of BC, we draw our right triangle. 1, 2, 3, 4, 5. So this length is 5 and this length is 1, which is the same length as AD. So now we know that the length is exactly the same. So let me make a correction here. This is bugging me. It's not A, it is AD. So the length of AD here is the square root of 26, which is also the length of BC. So now we've got enough information to be able to figure out perimeter. So whenever we figure out perimeter, again, we just add up the sides. So we have the perimeter to be AB plus DC, because I want to keep those together, plus AD plus BC. So if I do my substitution, AB is square root 13. DC is 3 square root 13. AD is square root 26. And BC is square root 26. So it's like Combining like terms, we cannot combine square root 26 and square root 13. Though that's like combining like 3x plus 2y. You cannot say that that equals 5 whatever. So it's not possible to put those together. But we can put the square root of 13 together, and there's 4 of them. This is 1 square root 13 plus 3 square root 13, which is 4 square root 13. And then we have 1 square root of 26 plus 1 square root of 26, which is 2 square root 26. This is in simplest form. We cannot combine them. So the perimeter would be 4 square root 13 plus 2 square root 26. I hope this helps. But these are just 2 examples of finding the area and perimeter of quadrilaterals on the coordinate plane.